Okay, so we're going to look at how to use the silicone control rectifier as a phase controller. Okay, so what we have here, so let's look at our diagram. We have an input coming out, okay, and the output is basically taken across the load at this point here, okay? So notice the position of the diode, okay? So we need to have a positive potential, right? More positive there, or negative there, right? And we can see that with our graph as to what's happening. You can see that here's the input signal, right? And here is our output. Notice basically we've clipped the bottom portion off, okay? That's due to the fact that our diode operates with a positive on the anode and a negative on the cathode. Okay, so let's talk about adjusting trigger point. R2 is a potentiometer. So what we have is as the potential comes through here, we have a voltage divider. And based on the values of these two resistors will dictate what their voltage drops are, okay? So R2 is adjustable. So let's say if we made R2 very large, okay, when this potential came in, he would have the majority of the voltage drop, okay? And provided his voltage drop is, let's say is greater than 0.7, when that signal, well, it depends on what point he's going to see 0.7, right? So as this signal, and that's what this is supposed to illustrate, as this signal's coming through, at what point is he going to see 0.7? Let's say we set his trigger point so that he's so large, he's going to see 0.7 almost immediately. Soon as he sees 0.7, this diode conducts, and once he sees the value that he likes based on his spec sheet, he will activate and short. And that's what we can see here. You notice the trigger point is just set very low because he's so large that he's going to get the potential right away. Okay, so that's why the output looks exactly like just a clipped, basic for all intents and purposes, just like the diode's clipping the output. Okay, so when the diode shorts, basically at the bottom of 0.7, the diode shorts, and then the output is generated through here, and you can see, and that's the resultant wave. Now, let's imagine we change his resistive value, so he doesn't have as much of a voltage drop. So it takes him longer to get the right trigger potential, and that's what this is showing here. We're adjusting R2 to set his value so that it takes him longer in the sine wave to get the potential that the diode needs to see and the gate needs to see. Okay, and what that would essentially do is it would hold off the rectifier until that trigger point was found, and then it would turn on, and the waveform would look a lot like this, right? Where it would just abruptly turn on at one point, and then the sine wave would continue. And then we can also increase that even further, right? If we increase the trigger point, we can make it right to the peak, and then we'd end up with something like this, like a waveform that is just basically cut in half on the top alternation, okay? And that's basically how the silicone control or a silicone control rectifier would phase control the output.